Everyone, Rhoda again with a Jack capsule on logarithms. We're going to use the properties of logarithms to solve this equation. 3 times 4 to the power of x is equal to 1 over 5 to the power of x. Now, there's more than one way to solve this equation, but what I want you to do is start by applying a natural logarithm, ln, on both sides, and then use the properties of logarithms to try and pull it apart as much as you can. I'd like you to pause the video here and give it your best shot, see how far you can get. When you come back, I will solve it. Here's the solution. The instructions were to start by applying a logarithm to both sides, so that's what I did. In the next line, I will use the properties of logarithms. Remember that ln is just a special case of logarithm with base equal to e, so I can use my usual properties to break this apart a little bit. On the left-hand side, I see a product. Inside of my logarithm, I have 3 times what's in the bracket, and I can separate a product inside of a logarithm into separate logarithms that are added together. On the right-hand side, I have a division, and I can separate my division into 2 separate logarithms that are subtracted from each other. So up in these notes here, I just used the first 2 properties. In the next line, I'll see what else I can do. So in my next line, on the right-hand side, I have ln of 1, which I recognize is always equal to 0. Log base anything of 1 is equal to 0. So I can get rid of that. That brings me here. Next, I'm going to use property number 3 in the notes that I've copied up here, which lets me take an exponent that's in a logarithm and bring it outside of the expression as a multiplication. That's going to give me, instead of ln of 4 to the x times ln of 4, that exponent comes out front as a product. I can do the same thing on the right-hand side. 5 to the x, that x exponent will come out front as a multiplication. So I can have negative x times ln of 5. So I've done all the logarithm steps of this problem. If you've got this far, congratulations, you've understood the properties of logarithms. All that's left to do now is solve for x. That's not really a logarithm problem anymore, it's an algebra problem. It might look intimidating because I have ln of 3, ln of 4, ln of 5, but those are just numbers. If they're distracting you from doing what you know how to do, just replace them with letters if you like. It's really the same thing as something like this. So if you know how to solve what I wrote in green, then you know how to solve what we've got over there in blue. You just have to kind of look past the logarithms and realize that they're just numbers at this point. So what would I do to solve a question like this in general? If it was 3 plus 4x equals negative 5x, I would put all the stuff with x to one side. So that's what I'll do. I can write ln of 3 is equal to negative ln of 5 times x minus ln of 4 times x. I just moved the x's to the back of their terms so that it's a bit more clear, at least for me. The advantage of doing that is on the right-hand side, I have a common factor of x, which I can take out. I actually have a common factor of negative x. So it's going to be a bit nicer if I take all of that outside as my common factor. That'll leave me with ln of 5 plus ln of 4. And on the left-hand side, I still have ln of 3. I'm trying to isolate x, so now what I can do is divide both sides by ln of 5 plus ln of 4. And finally, I have isolated negative x, so to isolate x, I would multiply both sides by negative 1. So I get the answer of negative ln of 3 divided by ln of 5 plus ln of 4. Just as some extra practice, I'm going to show you a couple other good ways to write the answer. So in the denominator, I have ln of 5 plus ln of 4. Remember our property for logarithms. A product inside the logarithm becomes a sum outside of 2 separate logarithms. You can do that in the opposite order as well. Here I have a sum on the outside. That means I could combine these into a single logarithm. Instead of writing ln of 5 plus ln of 4, I could have ln of 5 times 4 all in the same logarithm. In the numerator, it's actually nicer to leave it as negative ln of 3, but just for the practice, I'm going to point out that negative ln of 3 is the same thing as negative 1 times ln of 3, which means I have a multiplication out in front of the logarithm. I'm allowed to bring that inside as an exponent. So if you wanted to, you could rewrite the numerator as ln of 3 to the power of -1. Finally, if I just calculate those things out, 3 to the -1 is 1/3. 5 times 4 is 20. So here's another way to write the answer that's equally correct. I hope this helped. In the next video, we're going to use these properties of logarithms to solve a different type of problem.